Continuation of lecture 5, trying to explain. Well, I've just talked about what moment does, and we have seen the different types of supports we use on simple beam structures. A beam is a horizontal member. A beam is a kind of rod. Such member, one of the dimensions is far bigger than the other two dimensions. One of the dimensions, what is a beam? You will see that this dimension A, is far bigger than dimension B and dimension C. That's a beam. One of the dimensions is far bigger than the other two dimensions, or that the two dimensions are far less than one of the dimensions. That is a beam. That's also what is called a rod. That's a beam. Unlike something like a slab. A slab in a slab, you will see that two of the dimensions, A and B, are far bigger than one of the dimensions, C. Two of the dimensions, A and B, are far bigger than one of the dimensions, C. That's a slab or a plate or a sheet, whatever you want to call it. Is that a slab, a plate, or sheet? In such case, two of the dimensions are far bigger than one of the dimensions, or that one of the dimensions is far less than two, unlike a beam where one of the dimensions is far bigger than the other two. So now we're going to look at the supports. The supports we're talking about. We're going to create beams or slabs, which we use those supports. As we support them with those supports. We try to find out the type of reaction when it's loaded. Let's take, for instance, this is a beam. If you look at this beam, it's supported by a hinge support, what is called a hinge support. A hinge support, the one that has only two reactions, horizontal and vertical reaction, while the other support, it has horizontal and vertical reaction. The other one has only vertical reaction, the roller. This beam. Now, if we load this beam now, let's say we load it with a load in the middle here. Let's say 6 kilonewtons. We have the span. I have shown this, so let me just clean the type of reactions that is available here. And the span is, let's say the span is 7 meters. The span is 7 meters. The span is the distance between the two supports. That is more. The span is 7 meters. So in this beam now, we need this support A and support B. In this support A and B, we want to get the reactions. If we want to get reactions, the easiest way to do this is to now take, as I told you earlier, that bending moment is the product of the force and the perpendicular distance. So let's say we want to get reaction A. What we do is to take bending moment about support B. This thing means total moment. This sigma is total moment about support B is equal to 0 for this structure to be in equilibrium. Because if the total moment is only in equilibrium, that means the structure will be turning, because it is the applied moment versus resisting moment, and two of them must be equal, which implies that algebraically the total moment will be equal to 0 for the structure, for the beam to be in equilibrium. So for this support B to be in equilibrium, the total moment about support B should be equal to 0. That's just what I've just written here. So to get the total moment about support B,
What is taking moment? Taking moment is making every force on the structure a moment. What we mean by taking moment is making every force on the structure a moment. In this case, the forces here are reaction A, reaction B, and the load. They are the forces on the structure. And to make them moment is just to multiply them with a perpendicular distance. Let's start. Now, we're taking moment about reaction B. That's support B. That's what this says. Equal to 0. So to take moment of reaction A about B, that means reaction A times distance from the fulcrum, in this case, which is at support B, that will be 7 times reaction A. 7 is distance. Reaction A is the force. That's what made reaction A a moment. So 7 times reaction A. And about this support B, this reaction A will turn this way. It will turn this way. About support B, it will turn like this. About support B. So if it's turning this way, and I decide to call it, to say it's positive, that means any other one turning against it is negative. If it's turning this way, I say it's positive. Any other one turning against it is negative. If it's turning this way, I decide to say it's negative. That means any other one turning against it is positive. So that is that. So in this case, I decided that this way is turning is positive. So if it's turning this way about reaction B, and I say it's positive as I wrote it here, then the force 6 kilonewton is turning against it about B. It's turning against it about B, and as such it will be negative. Negative 6 times 3.5, because that's the distance of the force 6 from B. That's the perpendicular distance of the force from B. Then at B, the force, the reaction B, has no distance to itself. We are taking moment at reaction B. So reaction B has no distance to itself. So the distance of reaction B from itself is 0. So that's why reaction B will not create moment about B, because its distance from itself is 0. So that means the total moment, the forces that were able to create moment about reaction B, about support B, are reaction A and the force 6. Reaction B cannot create moment about itself because the distance from itself is 0. So that means this is equal to 0. So if this is equal to 0, from here that means that 7RA is equal to, this goes over this way, 6 times 3.5. It has gone over. The sign changes. RA, the reaction A, is equal to 6 times 3.5 divided by 7. So that is that, which in this case gave 3 kilonewton. So we have gotten reaction A. Now to get reaction B, vertical reaction, one we ask that the support A is supposed to have 2 reactions. What about the horizontal reaction? Because the load on the structure is vertically down. It has no horizontal component. Because what brings about reaction is an action. An action has to happen before a reaction occurs. So since there is no horizontal action, that horizontal resistance as reaction A will not appear. That horizontal resistance, that reaction at reaction A will not appear. So that's why we become more interested only in RA, which is vertical, because the action is vertical. So the reaction is also vertical. So let's now look at, even though the support A is supposed to have 2 reactions. So, but in this case, it has only 1. The other reaction did not occur because there is no action. generating it. So we now come to support B. To get reaction at support B, we have to take moment about reaction about support A. So we have total moment about reaction support A is equal to 0 for support A to be in equilibrium. So if we do that, we have one of the first reaction B now. So if we decide again to take reaction B turning this way, because about A is turning this way, if you call it positive again, you can also call it negative, it doesn't matter. If you call it negative, then any other one against it becomes positive. But in this case, I call it positive. So I have 7 reaction B, 7 times reaction B, I call it positive. Then 6, we go against it, about reaction, about support A. So minus 6 again, times 3.5. So in this case, reaction A will not have moment at its own position, about its own position, because the distance of A from A is 0. And that's why this is equal to 0. So RB is equal to 6 times 3.5 over 7, which in this case is still 3 kilonewtons, because the load is in kilonewtons. So now we make, after doing this kind of calculation, it's good to make what is called check or control. You check to know whether you made a mistake, because you can make a mistake, you're not God. You want to know whether you made a mistake. The only way where you now check, since you have taken moment about B to find reaction A and took about A to find reaction B, is to add vertical forces. Add vertical forces. The whole vertical force, because of the fact that this structure is in equilibrium, the whole vertical forces will give you 0. The summation of the vertical forces will give you 0. So if you now add, you have, because vertically positive, that's 3 plus 3, vertically up positive, vertically down negative, minus 6 should give you 0. If it didn't give you 0, you know that you've made a mistake. If it didn't give you 0, you've made a mistake. You look back and see where your mistake is coming from. So this is how to get reactions. Reaction A and reaction B. Yeah. The next thing we're going to deal with is to calculate bending moment here and the shear force. So that's the end of this episode.